Okay, so one of the things you have to be able to do with functions. Now, this is a function. Why is this right here a function? Because it passes a vertical line test. I'm not going to draw the vertical line because I don't want to mess up the graph because I need it for other purposes. But if you draw a vertical line, so if I take this right here, no matter where I draw this vertical line, it intersects it how many times? Each time, just once. So this is a function. So I'm going to call this f for right now. I'm going to call this function f. Now, one of the things you have to be able to do next class period, and you may have seen this in a previous course, because you do have some idea of this from last semester. But if I asked you, if I said find f of, let's say, 6. Find f of 6. All right, now remember, your function notation, remember the notation f of x? Okay, remember f of x means the same thing as what variable? No. F of x means the same thing as what variable? Y. Y. Okay, y equals f of x. Now remember, guys, last semester you had something like this. You had, if I asked you to graph y equals 2x minus 1, that's a line, right? One of the things you also did last semester was you talked about this in terms of functions. So basically meaning this, meaning that I can write y equals 2x minus 1 in function notation. F of x equal 2x minus 1. So I need for you to remember that y is the same thing as the notation f of x. It's a function. And we're going to talk more about that. So if you don't remember, it's no big deal right now. But remember, f of x means the same thing as y. Okay? So I'm asking this. I'm saying what f of 6 means is this, and it's a good idea to remember this way. It's saying this. What is y when x is 6? That's what that means. Because remember, f of x, what am I replacing x with? 6. So x is 6, right? We just saw that the notation f of x means the same thing as what variable? Y. So when x is 6, the question is, what is what? Y. So you go to your graph and you determine, well, first of all, where on the x-axis is 6? Where on the x-axis is 6? Right here, right? Okay, so if I take this right here and I place it over 6, where does it cross the graph? Right here. Y'all agree? Huh? Right here, right? Okay, so I need to put a dot right there. And then tell me the coordinates of that point. What are the coordinates of that point? 6, comma 7. Okay, so it helps if you actually write the coordinates out. So now I'm going to ask you, what do you think f of 6 is? 7. The answer is 7. So f of 6 equals what? 7. So what's the y value when x is 6? The y value when x is 6 is what? 7. Okay? All right, let's try this one. Let's find f of 3. So what do you think is going to go in that blank? So you have that in your test, so make sure you can do this. F of 3. F of 3, someone says 1. Does anybody else have an idea? 9, you said? Where do you get 9 from? Just tell me. Who said 9? No one said 9. Am I hearing something? Like I'm hearing things? Okay. Okay. I'm just wondering where this 9 came from, because when I look at the graph for x is what? 3. That's right here, right? And I look at the point right here. What are the coordinates? 3, comma 1. So when x is 3, what's the y value? 1. So what's f of 3? 1. That's all you do. And so then let's estimate this. We're going to estimate this one. What do you think f of 5 is? Estimate it, because it doesn't lie on a whole number. About 3.5? Okay, good. So when x is 5, here's the point right here. Y'all agree? So label it, it helps. This would be 5 comma 3.5. Right. So that would be 3.5. So it's about 3.5. I don't know if it is, but we're approximating it. What's f of 0?
7.
F of 0, she says 7. Does anyone disagree with her? No. Because f of 0, remember, you're asking what's the y value when x is 0? Well, x is 0 here, right? Always look at your x-axis to help yourself. X is 0 here. So when I look at this straw, where does that straw intersect the graph? Well, it intersects the graph here. So that means that when x is 0, y value is what? 7. All right, good. Okay. Now, one of the things that you also need to be able to talk about is this. What are the intercepts? Okay, intercepts. Now, remember, intercepts means where does the graph cross the x-axis and where does the graph cross the y-axis, right? Okay. Now, in my math lab, they may say, what are the intercepts? And there'll be a blank. How many intercepts do you see? 1. There's only 1 intercept. Does the graph cross or touch the x-axis? No. So there are no x-intercepts, right? Okay. But there is a y-intercept. And depending on how you're asked to write it, because sometimes you're going to be told to write as an ordered pair. Sometimes it won't say rise in ordered pair. If it doesn't say rise in ordered pair, then I could have easily just said what? 7. Where are you getting 1 from? Tell me where you getting 1 from. I'm just a little worried about that statement. Where are you getting 1 from?
I would say 0.
Okay. All right. So it's not 1, right? You start right here. How can that be 1 right here? How could anything with this be a 1? Okay? All right. So 7. Now, as an ordered pair, what would you write it as? Oh, let me do it here. R what? 0, 7. Okay. Now, suppose on the worksheet it said this. It said, what's the x-intercept blank, and then the y-intercept blank. What would you say for the x-intercept? You'd have to say what? None. You'd say none. The y-intercept, you'd say 7 or 0, 7. Okay? All right. Now, in a little while, we'll come back and I'll give you another set of these. Oh, no, I don't have another set. So you have to use the same set. And we're going to talk about increasing and decreasing. It's not difficult. It is not difficult. Okay, so I'm going to leave this alone because that's not a function. I just want to talk about functions right now. Okay, y'all agree that's not a function, right?
Yes.
Because it fails the vertical line test. So I'm going to leave that alone. Okay, now let's go to this one. So in that one, let's look at this graph, and we know this is a function because it passes the vertical line test. No matter where I draw this vertical line, it intersects it once. Y'all agree?
Yes.
Okay. Now, suppose in this particular case, and let's call this function g for right now. Let's call it g. You can name a function with using different notation. F of x, g of x, h of x, whatever you want to name it as. So we're going to call this function g. And so let's suppose I want to know what is g of negative 5. G of negative 5. What do you think that's going to equal? Okay, so one person said 1, another person said 1. Any disagreements? What? What'd you say? 0. So when x is negative 5, so I locate negative 5 on the x-axis, correct? Y'all agree that's this right here? Okay? The point that's associated with it is this point right here. So that's
Oh, yeah, I was looking at.
yeah. It kind of looks like these numbers on the x-axis are not showing very well. But this is -5, this is -6, and this is -7. So when x is -5, what's my y value? 1. Okay. When x, so let's find g of 0. When x is 0, what's my y value? 2. Y'all agree? Okay. Let's find g of 4. G of 4. What do you think that is? Huh? So wait, what now? What'd you say? Did someone say negative infinity? Okay, I'm hearing things, but if you did, I need to mention this, and guys, this happened before. That's why I said it. G of 4 is going to be a number, so you're not going to say negative infinity or positive infinity because that's not a number. Okay. All right. So G of 4, you agree? That's this point right here. So that's 4 comma what? So what's G of 4? Okay. All right, let's find the intercepts. And notice I put the S in parentheses because there may be 1, there may be 2. In terms of the Y-intercept, let's do that first. Is there a Y-intercept?
Yes.
Yes. What is it? 2R 0, 2, right? What about the X-intercepts? Are there any? Yes, there are how many? 2. So if you want to list them individually, you could say, what's that, -6, comma, 2, right? Now don't put that in parentheses. No, because if you put it in parentheses, you're indicating that's a point. So my x-intercept is not the point -6, 2. Now if you want to put this as an ordered pair, then you're going to need parentheses. So you'd say -6, comma what? 0. And then the other will be 2 comma what? 0. So make sure you did not put this one in parentheses. Okay? All right. Then let's look at the next one. All right. Let's look at this one. Now this is where we start looking at functions where there's a hole in the graph. Okay, so let's talk about the domain in this case now. We're going to talk about domain and range. Okay, so remember when we talked about the domain for this one right here, for this one, we said we needed to use brackets and parentheses, right? Brackets with the numbers and parentheses with infinity, negative infinity. All right. Now, when we said that the range here, that the range was parentheses negative infinity to 4 with a bracket, the bracket with the 4 indicates that this point is part of the graph. See this point right here that I'm pointing to? That's part of the graph. So every point that I'm pointing to are solutions. They're points that are part of the graph. Now when I get to this you'll see an open circle. So you'll see an open circle, and then watch, versus a what? Closed circle. There's a difference between the two. So the open circle right here means that this point is not part of the graph. This is where my graph starts, but that particular point and this point, that open circle, denotes what point? That's -4 comma, what do you think? 2. All right. So that point right here denotes the ordered pair -4, 2. But -4, 2 is not on the graph. Now I'm going to ask you this: is this point here that I'm pointing to, is that part of the graph? Yes. but this one's not because there's an open circle. So there's still an infinite number of points on the graph, but this is not one of them. This is where the graph starts, but I can't include it when I'm discussing some stuff. All right, so let's call this function h. First of all, let's find h of, let's say, 2. Most of you, I think all of you can do that now. H of 2. So what's the y value when x is 2? So it looks like it's what? 6. So if you need to label it, so 2, 6. So that's 6, right? So h of 2 is 6. So 6 goes in there. Nothing else goes in there. Only 6 in that blank. What's h of 0? 5 right here. Okay. All right. Which happens to also be the y-intercept, right? Mm-hmm. So do y'all agree the y-intercept is 5? Yeah. Now that should not be an issue because remember when we graph the lines and you're asked to find the y-intercept, what did you let x be? 0. That's what this is, right? X is 0. So whenever you're finding a function value when x is 0, you're actually finding the y-intercept. Now, can I determine h of negative 4? No, because negative 4 is not part of my graph. What do you see at negative 4? An open circle. So if you're asked to find something like h of negative 4, you know that that's not part of the graph. You're just going to say either none. A better word would be to say does not exist.
Can you say no?
No, don't say no. Just say none. Just say none. Okay, so h of negative 4 does not exist. Okay? All right, now let's talk about the domain and range. All right, so to find the domain, I'll go along which axis? X-axis, right? Domain is a set of x coordinates. So is this where I start touching the graph right here? No, I start touching the graph when I get to this open circle, right? What is that x value? Negative 4. But I can't use it because I see a what there? An open circle. So I've got to use parentheses. So the domain will be parentheses negative 4, comma, and then do I ever stop? No. So all the way to what? Infinity. So that's the difference there. Open circle. It's not part of the graph. So you cannot use brackets. You have to use parentheses. Now compare that with this one where you see a closed circle here. So let's do the domain for that one. First of all, is this a function? Yes, because it passes the vertical line test. No matter where I draw a vertical line, it intersects it once. But when I look at this function, where do I start touching the graph? At negative 7. Is that part of my graph? Yes. Yes, so I got to use what? Bracket negative 7 all the way to what? Infinity with a parentheses. Okay? All right, let's talk about the range. The range. Okay, so for the range, I go along the y-axis, but I go from bottom up. So is this where I start touching the graph? At this y value right here? No. I start touching the graph here, right? Mm-hmm. When y is what? 2. But there's an open circle. So this point is not part of the graph. So I got to say what? Parentheses 2. Is this where I stop? But I'm just answering the question, though. You're right, it is infinity. But is this where I stop? No. Do I stop at this arrow right here? No. It keeps on going. It's all the way to what? Infinity.
So would I be correct to say that 2 isn't a stopping point on the Because there is a point on it, it's just not the stopping point.
What do you mean by a stopping point?
Like how on the second one, it's got the closed circle, so you know that your line stops there.
No, what I'm not sure what you mean by the word stop, because this is where we start.
Oh yeah, well, starting point, that's what I meant, starting.
Okay,
So up on the top one, you're saying
we
that-
start here, but it's not part of the graph.
But it's a point on the graph.
No, it's not a point on the graph. A point on the graph. Remember, when you graph lines, you were graphing solutions. So all these points are solutions, but not this one. Now you may say, well, why do we put an open circle there? Because if I were to magnify this right here, I just want to show you. If I were to magnify from -4 to -3, expand it. If I were to expand this, here's what happens. Okay, so let's say this is -4, and let's say this is -3. Y'all agree that there's an infinite number of numbers in here, right? There's like -3.76554. There's -3.82785,021, and all that, right? So you have all kinds of numbers in here. So what's happening is that from -3 to 4, your graph does this, right? So it does something like this. Okay, so think of this as this little piece here. So you have all these x values right here, but it starts here. So you got to put an open circle here because that's where it starts, because you still have a bunch of little points right here.
So
That's part of the graph.
So it's like a margin?
Huh?
It's like a margin?
Yeah, it's kind of like it's got to start somewhere. All right, so you can't just say it starts at -3.9, because it doesn't. Because there's some other numbers closer to -4. You have a so if I look at -4 and this is -3.9, do you still have some numbers in here? Yeah. So you got to look at it like that. So it kind of like blows your mind in some sense. Like, wow, I never even thought about it that way. That if you look at little chunks, there's still some numbers between those. So that's why even though it's an open circle, you still got to use it in your answer, because you still have a bunch of x coordinates right here that's part of the domain and part of the range, these y coordinates.
Why did you put the parentheses on the infinity for?
We always use parentheses with infinity, negative infinity, because it's not a number. It's not bounded. There's a difference between saying -4 to 8 with a bracket. The 8 is bounded. You stop at 8. There's no stopping. You can't stop here. Infinity keeps on going. Infinity is not a number. It's a concept. So you always use parentheses. And is that clear? With infinity, negative infinity, you're always going to use what?
The opposite.
I'm sorry?
I confused myself because I wrote it the opposite way on my paper. So
What do you mean by the opposite way?
Like I put brackets instead of putting parentheses for that.
Oh, okay. All right. Okay. Now, so hopefully when we expanded it, you got a better idea of the fact that you still have an infinite number of numbers here. You never really looked into that fact, but you have all kinds of irrational numbers in here, all kinds of rational numbers in here. There's an infinite number of those. Then you can take this little piece right here and expand it further, and you see you still have an infinite number of numbers there. And then you can go all the way to -4. Okay, so that's why in some functions you'll see open circles and closed circles in some of those. All right? Okay. Now, let's talk about the range on this one. What do you think the range is? Say it again. With bracket or parentheses? Bracket, good. So bracket, -8 all the way to what? Infinity. Infinity is always parentheses, because it's infinity's not a number. It's not a bound. You're not stopping there. Okay. All right, and let's just find. Let's call this f of x, the function f. Let's just find f of. Let me find one that works pretty well. Actually, none of them do. Let's look at this one. F of negative 2. Approximate f of negative 2. F of negative 2. So that's about here, right? What's that y value? Approximate it. About negative 4.4? Yeah, I mean, we're approximating. So anything close to negative 4.4, so negative 4.3, negative 4.25, you know, someone could have said, well, I'm going to just say negative 4.3876. Go for it. All right? We're really not sure what it is. We're approximating this. All right. So that was that one. Now, let's look at this one. Let's look at this one right here. Is this a function?
Yeah.
Yes. So let's call that function h. What is h of 4? H of 4. What'd you say? 7. I'm going to ask you this now. What is h of 1,000?
780?
Huh?
7.
It's 7 as well. Yo, look at this. It's a horizontal array, right? So all these y values are what? 7. Remember, this arrow keeps on going. So all these y values are what? 7. So when x is 1,000, let's say this was 1,000 right here. What's my y value? 7. So that's 7. So if I'm using any x value in the domain, I could say 8.2. What is h of 8.2? 7. Okay? All right. Now, what's the domain? Remember, domain, you go along the x-axis. So when I go along the x-axis, I start here, right? But what do you notice about this point? It's open. What's that y value? I'm sorry, that x value? Negative 6. Okay, so parentheses negative 6 all the way to what? Infinity. All right. The range? You go along the y-axis, right? So I'm going to ask you this. When I go along the y-axis, where do I start touching the graph? Right there. And in fact, I don't go any further, right? This is it. This is it. What are those y values? 7. So compare what we're about to do with what we've done before. Notice that in every problem we've done before, the domain and range were intervals. So the domain here, how many numbers are in this domain? 2? An infinite number. So if you go back to the others we've done, how many numbers are in the domain and range over here? An infinite number. So we use interval notation for those. Whereas over here, how many numbers are in this range? 1. What is it? 7. So it's a finite set, right? Now remember we talked about finite sets last class period, domain and range. Remember the ordered pairs? So this is a finite set. You're gonna write it like this. You're gonna say it is just 7. Remember the braces? So notice the difference between these two. The domain here is an interval. The range here is one number. All these y values are what? 7. So you write it as a finite set. All right. Let's look at this one. Let's find the domain of this one. Okay, so domain, you go along the x-axis. Do I start touching the graph at this point right here? Is this where the graph starts? No. Is this where it starts? No. Where do I start? Negative infinity. So I go from negative infinity all the way to, do I stop here? Because that's where my arrow is. No. Keep on going. So all the way from negative infinity to what? Positive infinity. Okay, what about the range? So the range, you go from bottom up. Is this where the graph starts at this arrow? No, because remember it keeps on going down. So where do I supposedly start? Negative infinity. Because there is no really bottom point. There is no lowest point, right? Because it goes down like this, so it never stops. So it's negative infinity, parentheses, negative infinity, all the way to what? Positive infinity. Okay, now let's look at this one. Okay, let's look at this. Now this right here is an open circle. You really can't tell, and this is a closed circle. Okay, so let's call this k, function k. What is k of, let's say, 7? Negative 3, because that's this right here, right? What is k of 4? 0. That's your X-intercept. All right. What is k of negative 3? Positive 7? All right. What is the Y-intercept? 4 or 0, 4. The X-intercept? 4 or what? Not 0, 4, but 4, 0. Okay. Okay, now let's talk about the domain. All right, so tell me, where do I start? Negative 5 with open circle, so I got to say parentheses, negative 5, comma, all the way to 7 with a what? Bracket. Good. Okay. So there are no arrows on this one, so there's no infinity being involved. So from negative 5 all the way to 7. All right, let's talk about the range. So the range, where do I start? Right here, because there's no arrow, so I start here. That's y value of negative 3, bracket or parentheses. Bracket, negative 3, comma, where do I stop? At 9, but I got to use parentheses. All right, because that was an open circle. All right. Okay, now look at this one. So this right here has arrows on both ends. So there are no open circles on this one. So every point on the graph will be a solution. All right, let's call this f. Let's find f of 1. What's f of 1? 2, right? Okay, f of 1 is 2. What's f of negative 1? Negative 2. So remember, f of 1's here, so if you need to label the point, you would say 1 comma 2. So again, remember that f of 1 means what's the y value when x is 1. So the y value when x is 1 is 2. Same thing here. This right here is the point negative 1, negative 2. So f of negative 1 means what's the y value when x is negative 1. So the y value when x is negative 1 is negative 2. Okay? How many y-intercepts are there? 1. 1. In fact, I'm going to ask you this. Can a function have more than one y-intercept? Because you saw this. You saw that a function can have more than one x-intercept, right? In fact, this one has how many x-intercepts? 3 of them. Yes, 3 of them. 1, 2, 3. So 3 of them. But can a function have more than one y-intercept? No? Yes? Okay, all right, let's talk about this. Let's look at it. So I'm going to draw a graph that has more than one y-intercept. Okay? So let's say I did this. Does this graph have more than one y-intercept?
Yes.
In fact, for this x value right here, how many y values are there?
2.
2. So if it has more than one y-intercept, then it fails the vertical line test.
Mm-hmm.
It fails the definition of function, because I'm going to ask you this. Let's just suppose I look at these 2 points right here. All right, these 2 y-intercepts. Let's call this 0, 8. Let's call this 0, negative 4. When x is 0, how many y values are there? 2. Definition of function says that for each x coordinate, there's got to be exactly one y coordinate. So can a function have more than one y-intercept? No. A function cannot have more than one y-intercept. A function can have at most one y-intercept. Because if it has more than one, it automatically fails the definition of a function. Because remember, when a graph crosses the y-axis, what's my x value? When a graph crosses the x-axis, the y-axis, what's my x value? 0. So if it has more than one y-intercept, then that x equals 0 is attached to multiple y values. All right. Now, there's only one y-intercept. What is it? You can say 0, or you can say what ordered pair? 0, 0, which is the origin. The origin. Now, let's approximate these 2 x-intercepts. But there are how many x-intercepts? 3. So you can say, it looks like this one's what? About negative 2, now remember, be careful. This is negative 1.5 here, right? So that's about negative 1.75 maybe? Y'all agree?
Yeah. Sure.
And this one is obviously what?
0.
0. And this one, be careful, this is 1, this is 2, this is 1.5, so about 1.75. All right. So those are your x-intercepts. Okay, now let's talk about the domain. What do you think the domain is? All right, so you agree with what Trey said? So remember, for the domain, you go along the x-axis. So even you see this arrow right here, right? Now remember, the arrow doesn't mean that's where you start. The arrow means that this function keeps on going this way. So that's the idea from negative infinity all the way to what? Positive infinity. What about the range? Same thing. See, you keep on going down here, so there's no low point. There's no lowest point. So it's from negative infinity, and there's no highest point. It just keeps on going to what? Positive infinity. Okay? All right, any questions? All right, so those points, so far, those points should be easy for the tests. So if you go back to your study guide where it says, also you'll be given a graph of a function. This function will have an open circle on it. Okay? You will be asked to find the following. The domain and range. So I think you can do that one. Find the domain and range, and I think you can find function values. And I think you can find intercepts. Okay? All right, any questions at this point? We're going to look at this a little bit more. Let's look at this right here. Now, there are no grid lines here like there are with the others, so I'm a little bit more careful with what I asked you. All right, but I think, and let's call this function h. Let's find h of, let's say, 2. That I know you can find. H of 2 is 0, because that happened. Okay, let me not say it just yet. How many x-intercepts are there? 3, good. Remember, an x-intercept is where the graph crosses or touches the x-axis. Because remember, the x-intercept is where y is 0, right? So y is 0 here, y is 0 here, and y is 0 here. So there are how many x-intercepts? 3. So my x-intercepts are -3, comma, 2, comma, and 5. So when we said h of 2 was 0, that's because this h of 2 happens to be the x-intercept. And when I label that point, that's the point 2, comma, 0. What's h of -1? Let's just, oh, I'm sorry. Yeah, so that's not a good one to use, is it? So -1, just kind of do something like this. Yeah, just use a ruler if you can. So it's about right here, right? So it's more than 3.5. So let's say about -3.8, -3.9, something around there. Now, if you had put what now?
Shouldn't your equal sign be squiggle line since we're estimating?
If you're estimating, you would technically say this, yes, yeah, because it is an approximation. No, you're right. I should have said. Now here, right here, now that's going to be an equal sign, right?
Yes.
But here, since I'm approximating this, yeah. No, she doesn't get any bonus points, but she gets the fact that she was able to tell me something. All right. What is the range? The range is easy to find. Where, remember, you go along the y-axis. Where do I start touching the graph?
-4.
Very good. So from -4 all the way to what? Infinity. Are there any holes in the graph? No. So I'm going to use bracket -4, comma, all the way to what? Infinity.
Now, if you did want to include all the points on the graph, would it be like
Wait, what now?
like if you didn't want to include all the points?
Well, I can't just automatically not include
I'm
something.
saying like, would it be like what's those lines? The space line?
No. I'm a little confused as to what you're asking.
Like, would it be a not a dotted line? Are you asking there's like a hole? No, it's like it's.
Okay, so I'm not sure if you're referring back to vertical asymptotes or not, because we haven't talked about that. There are some graphs that we're going to look at in here, the second half of the course, where you may have a graph that may look like this. So you have a vertical asymptote,
Yeah.
and you have this part looks like this, and then this part looks like this.
No, I just mean like the dot, just that line. In the middle.
Well, I mean, it has a vertical asymptote. The idea around a vertical asymptote is where part of the graph goes towards it. It's kind of like a magnet, goes towards it, but doesn't touch it. So we haven't talked about that yet. Okay, so it's a good idea. It's a good idea, but let's just not focus on that right now. But hey, always think things like that. Always think out the box and see what you can do with it. All right, now here I can't talk about this. I can't talk about function values here because for one thing, this is not a function because it fails the vertical line test. So when x is -3, we talked about that last time. How many y values are there? An infinite number. But I can. It's a relation though, right?
Yeah.
Okay, all of these are relations. Not all of them were functions, but all of them were relations. But I can talk about domain and range. So what's the domain here? Domain, remember, go along the x-axis. It is just -3. Y'all agree? So just like we did a while ago, you're just going to put -3 as a finite set. But the range is different. Remember, a while ago we had a line, a horizontal line. Here we have a vertical one. The range is different. These are both arrows. You're going from where? negative infinity to positive infinity. Okay? All right. What? The domain, I forgot about the domain there. What do you think the domain of this one is? Yeah, negative infinity to positive infinity. Yeah, negative infinity to positive infinity. All right? Okay, so now I'm going to give you another handout. What?